So now we're going to look at sampling principles and strategies for how do we get these samples of people. So first, let's look at our research question. Can people become better, more efficient runners on their own just by running? So can we affect it in that way? If we did that, who is our population? Well, our population is all people because it's can people become better, not can marathon runners, not can athletes, it's can people. So that's our overall group. The big umbrella is people. Now, under that big umbrella, I have to sample people in order to get this generalized. So I could use a sample of a group of adult women who recently joined a running group. If I use that as my sample, though, I have to be careful with who I can generalize that to. So if I use my sample as a group of adult women, I've now limited myself to a population of adult women only. If I really want to do all people, I would have people that are athletic and not athletic, males and females, and all different characteristics. That is not really always possible for us. So sometimes we have to study subgroups of our population and then have multiple studies with those subgroups that we can then start looking at together. So here is an example of anecdotal evidence in early smoking research. So a lot of anti-smoking research started in the 1930s when it became very, very popular. While some people seemed very sensitive to the smoke, others seemed to be really unaffected. So anti-smoking research got a lot of resistance at first based on what they called anecdotal evidence, such as something like, oh, my uncle smokes 3 packs a day and he's totally fine. And so that evidence is based on a very limited sample size of people that you know. Your uncle's health characteristics are very complex and they may not be like the next person's health characteristics. So this is the problem with generalizing based on anecdotal evidence. Just because your uncle is fine doesn't imply that everyone is fine. We have to investigate further. So because smoking was such a complex human behavior, people smoke for different reasons, they have different health, different baselines, it gets very confounded by human variability because there's so many factors there. And so in time, researchers were able to get very large samples of smokers and look at trends between studies. And when we looked at the trends between multiple studies with large groups, we saw that there were negative impacts, and that's how we moved from anecdotal evidence to solid scientific research. And so the census is another good example of getting those large groups. A census is when we take everyone's information in the U.S., right? It occurs repeatedly throughout each decade. We have it occur every so many years. And so the question is, wouldn't it be great if we could just contact the entire population? If I could just ask all smokers. That is called a census because it's, again, like what we do. But is it realistic? How much money in postage, just postage alone, would you spend trying to get in touch with every single person that smokes? It would be astronomical. It would be huge. So this is why a census is often not reliable for us. There also are other problems. It's difficult to track everyone down. We don't have a comprehensive list of all smoking people's addresses. Populations don't stand still. They're constantly moving. They're changing apartments. They're changing houses. And a lot of times this is more complex than just sampling because the data is not convenient to find. So here's another example with illegal immigrants are reluctant to fill out census forms. So this is a portion of people that we're missing in our census, but that are in the population of the United States. This shows another example of an issue. So if I want to be able to think of exploratory analysis where I can infer answers, sampling is going to be a natural process for us. You want to think about sampling like something you're cooking. You taste a small piece of that, and based on that small taste, you say, okay, the whole dish is good or not good, or the whole dish needs salt or it doesn't need salt. And then when I taste a spoonful of soup and I decide that it wasn't salty enough, that would be an exploratory analysis. Then I might try another spoon and I might stir it and try another spoon to see what happens there. So if I can then conclude after I've stirred it and rechecked it that, okay, I still don't have enough salt, then that's an inference that I've made after an exploratory analysis. So for your inference to be valid, the spoonful that you tasted has to represent the entire pot. That's why we stirred the pot, to double check and make sure it represented it accurately. If your spoon only comes from the surface and the salt is collecting at the bottom of the pot, it's probably not going to be representative. If you stir the soup thoroughly before you taste, you're going to get a better picture of what's going on. A non-response sampling bias, so we're talking about bias now. Bias is essentially when a question is biased towards a group of people, or when we have something that could be considered unfair. So we have non-response bias, which happens a lot, and that's where only a small fraction of the people that you randomly sample choose to respond. This happens all the time. You get a survey in the mail and you chunk it in the trash. We've all been there. The sample may no longer be representative of the population because people with different characteristics have not responded. So that's why this is called a non-response bias. Voluntary response is when the sample consists of only people who volunteer to respond. So think about like those commercials where it says to call this number if you've had this complication, or call this number if you've had this experience. How many people are really going to call that number? Are they going to be representative of everybody? No, because the people who are calling that number are very, very invested in whatever they're asked to be calling about, because they're picking up the phone and calling. So these types of samples in general are not scientifically utilized if I'm trying to make an actual inference because of possible bias. So another example is this quick vote. When you're having those short little votes pop up in your internet box, that is going to be a voluntary response. Or if somebody posts a survey on Facebook, that's a voluntary response. You're volunteering that information. A convenient sample kind of overlaps a voluntary response. This is people who are convenient to you. So if I post a survey question on my Facebook, that is contacting people that are convenient to me. They also have to voluntarily respond to what I've put out in my status. I didn't contact them directly, individually to do it. So there's overlap that happens here. If you're at the PTO meeting at your kid's school and you survey only the PTO parents, those were people who were convenient to you. And they are, if that in that way, they're going to just be not as scientifically significant or as respected as a sample. A historical example of a biased sample that gave very misleading results would be in 1936, Landon sought Republican presidential nomination, reopposing the election of FDR. That's a pretty significant example of bias. The Literary Digest polled 10 million Americans and only got responses from 2.4. That sounds like a huge number. But what percent of people is that really that responded? The poll showed Landon would likely be an overwhelming winner and that FDR would get 43% of the votes. The election result was that FDR won with 62%. Think about how off that was. It's because the entire population of the U.S. is so much larger than 10 million people, and 2.4 million is just a drop in the bucket for most of our states. That's not even a whole state's population for the majority of the United States. So the magazine was discredited because of this poll and was very soon discontinued. And this has continued to plague the U.S. as we have had elections from this point on. We are still having this problem with predicting elections. What went wrong here? Well, first of all, the magazine only surveyed its own readers, so that in and of itself are people who are out there who are politically active as opposed to the average American. They only looked at registered automobile owners. Well, that's cutting out your lower class of people, or people with low socioeconomic income, maybe people who live in large cities that don't own a car because they use public transportation, and they had to have a registered telephone, which again is cutting out a huge group of people. These incomes were also well above the national average of the day. They had to have extra income to subscribe to this magazine. And this is the Great Depression. There wasn't a lot of extra income. So this resulted in a highly skewed look of things. And so that was kind of the start of the downfall of the political polling system. This was based on a sample size which seemed so huge But because it was biased, that huge sample did not give us an accurate prediction. Again, people voluntarily answered this. Right away, once it's voluntary, we know that it's not really something we can generalize. And if we move back to the soup analogy, if we don't stir the soup, it doesn't matter if you have the largest spoon out there. It's not going to taste right. We have to stir the soup. So we have to use a scientific sampling method for us to be able to make inferences. Here's a practice question. A school district is considering whether it will no longer allow high school students to park after 2 recent accidents where students were severely injured. As a first step, they survey parents by mail, asking them whether or not the parents would object to this policy change. They sent out 6,000 surveys, and only 1,200 are returned. Of these 1,200, 960 agreed with the policy change, and 240 disagreed. Which of the following statements would be true? So pause the video and just think on this for a second. It would be 1 and 3. Some of the mailings may never have reached the parents. We've certainly seen that in the pandemic world right now. It's also possible the majority of parents of high school students disagree with the policy change. It is possible because we had a 960 and then 240. Notice I did not say it is. I said possible. So that's the key thing that you have to keep in mind there. In observational studies, researchers are going to collect data in a way that doesn't interfere. We're just observing. We're not interacting directly with the sample. We're not changing the environment. So the results of an observational study can be used to just kind of say there's an association here, and we probably want to check it out a little bit closer. When I want to investigate it a little bit closer, I want to make sure that I have a really good sample. So using everything that we just talked about, we want to make sure that they're all based on implied randomness, because the one thing that voluntary convenience didn't have in common is they weren't random. So in order to have a good sample, I have to use random selection. If observational data is not collected in a random framework, they're not reliable. So I can do an observational study, and I can say, okay, I'm going to use a random number generator, and then I'm going to use the observations from these people. So you're still observational, but you can get some randomness to it. Most common random sampling techniques would be simple, stratified, and cluster sampling. Let's take a look. If I am doing a simple random sample, I am randomly selected cases from the population. Here's where it gets difficult. I need to know who is the entire population. That gets to be very tricky, right? What about all women? If I have all women in the U.S. as my population, it's very hard to find a comprehensive list of this unless you're looking at a census. And remember, a census is going to be no longer accurate post things. So I have to have the entire population. I have to use a random generator, and I have to then hunt those people down to get their data. This is very difficult to do, and this is why it's not done a lot. If you're in, say, a college setting, you could get a list of every freshman at the college. That's pretty easy to do. Then I could random sample them. But the larger the population, the more difficult, because you have to have the list of everyone. A stratified sample is kind of groupings. We're going to take a simple random sample from each grouping. So think about this like sections of statistics. They have different sections that run at the same time. I could get a class list from each section. And then I could take a simple random sample from each one of those sections. That would be a strata. And that would conduct a stratified sample. A cluster sample is different from that because we take a sample of clusters. So this would be taking all of the statistics sections, and those would be clusters. And if I pulled section 3, I sample everybody in section 3. Whereas a stratified sample, I randomly sample people inside of section 3. This is all of section 3 is sampled. So that's kind of the difference in a cluster and a stratified sample. Clusters are not typically made up of homogeneous observations because they're typically pre-existing. So when we take the simple random sample of clusters and then we can make simple random observations from sample clusters, it gives it a little bit more integrity. It's still a little wishy-washy, but it gives us a better justification. So I can practice this by the scenario given, take a minute to read the scenario, and pause the video and respond. Here, cluster sampling is going to be the least affected because each area is broken up into distinct and unique neighborhoods. So my clusters aren't homogeneous. So if I pick a cluster with large homes and then I pick a cluster with small homes, that's not really going to work. I'm not going to get a very unified look here. I would want to use simple random, I would want to use stratified, or I would want to use blocked sampling. Of all of those, cluster sampling is probably the weakest one because clusters are pre-existing. They have their own characteristics that may not match that of the entire area.